All right, today we're going to pull back the curtain on the invisible rules that pretty much run our lives. I'm talking about everything from how your phone works to the choices you make every day. It all comes down to these surprisingly simple things called decision structures. So let's dive in and break down the hidden logic that powers our entire world.
Think about it. Your day is just this constant stream of choices, right? Yes or no, pass or fail, go left or go right. They feel like these super simple split-second decisions. But what's actually going on under the hood when we or a machine make one of those calls?
And this right here is the main idea for today. Inside your brain, you're running logical tests all the time. The craziest part, the basic logic that you're using, it's the exact same logic that powers all the algorithms in the tech you use every single day.
So let's start right there, with our own brains. How do we actually deconstruct this hidden logic that's always running in the background, guiding our every move?
Okay, imagine you're a computer program for a second. You've just been handed this list of students and their exam scores. Your one and only job is to fill in that blank status column. So, how do you decide who passed and who failed? What's the rule you're going to follow?
To figure this out, we've got to understand the most basic, most fundamental tool that any algorithm has. And that's the simple yes or no test. This is the absolute bedrock of how computers think.
This test has a name. It's called a logical expression. And here's the key thing to remember. It's a question that can only have two possible answers. Not maybe, not sometimes, just a clean, simple true or false. That's it.
So, for our student problem, the logical expression is this question right here. Is the score greater than or equal to 50? For every single student, the answer is either going to be a hard yes, which is true, or a hard no, which is false. There is absolutely no in between.
And boom, here's the result. Just by applying that one simple rule to each student, the algorithm can perfectly fill out the entire column. Look at student A with a 48. Is that greater than or equal to 50? The answer is false. So they fail. What about student B with exactly 50? Well, the answer is true. So they pass. It's so simple, clean, and incredibly efficient.
But, life is rarely about just one single question, is it? To handle the real world in all its complexity, we need to start connecting these simple little tests together.
Let's use voting as an example. So here's the situation. You know you're old enough to vote. You're over 18. That test is true. But what if you're visiting a friend in a totally different country when they're having their election? Can you just walk in and vote? Of course not. So just being over 18 isn't enough. We obviously need another test.
And the way we connect these tests is by using words like and or. With and, both things have to be true. To vote, you have to be over 18 and you have to be a citizen of that country. If even one of those is false, the whole thing is a no-go. But with or, it's different. Only one of the conditions needs to be true. Like, I'll drink coffee or tea if I feel sleepy. Either one works. This is how we start to build much more complex and realistic logic.
Okay. So what happens when there are more than just two possible outcomes? When it's not just pass-fail or yes-no. Well, this is where we have to build something called a decision chain.
Right, so we've totally figured out pass or fail. That was easy, just one question. But how does an algorithm assign a specific letter grade, an A, B, C, D, E, or F? Now we have a whole bunch of possible outcomes, so one little true-false test just isn't going to cut it.
The solution is basically a chain of questions, like a waterfall. The algorithm asks them one by one in order, and it stops as soon as it gets a yes. So first it asks, is the score 90 or above? If yes, great, it's an A and we're done. If the answer is no, it just moves to the next question. Is it 80 or above? If yes, it's a B. It keeps going down this ladder until one of the conditions is true. And if it gets all the way to the bottom and every answer was no, then it just defaults to an F.
And would you look at that? Here's the final table. That logical chain fills everything out perfectly. Let's take student C, who got an 89. The algorithm asks, is it greater than or equal to 90? Nope. Okay, next question. Is it greater than or equal to 80? Yes. So the grade is a B, and it stops right there. See? It's a really ordered and efficient way to handle a bunch of different outcomes.
So now that you understand this logic, you're going to start seeing it absolutely everywhere. You can pretty much think like an algorithm yourself now.
Think about it. What's the logical expression that makes that low battery warning pop up on your phone, or the one that gets you free shipping on a website? What are the conditions that have to be met for your password to be considered strong? These are all just decision structures, running on the exact same logic we've just been talking about.
When you really boil it all down, it comes to this. From our own biology to the massive digital network that connects all of us, the world just runs on rules.
And these rules aren't some kind of magic. They were written by people. So I guess the final question I have for you is this. Now that you can basically read the code behind all the decisions happening around you, which rules would you want to rewrite?